All right, hey guys, this video is for group 1 and we're doing a little jigsaw this morning, so you want to make sure that you write down notes on this topic because you're going to be in charge of explaining this to other members of the class in a little bit. So your learning target is I can determine whether a graph represents a function. So you guys are just going to be focusing on the graph perspective. And we're going to start by talking about relations and functions, okay? So as this little article says here, relations and functions are the most important topics in algebra. First of all, there are so many different types of functions, and we'll explore those pretty soon. But also, this is going to come up in, trig, in pre-calc, in calculus, in any of higher math classes that you take, because functions are a way for us to translate a real-world situation into a graph or an equation or something like that. And that helps us extract meaning from it or maybe make predictions about it. So what we're going to talk about for this particular section is just graphing, but there are different ways to represent functions as well. So there's two words that get thrown around with this, relations and functions. And so when we talk about a relation is any relationship between x and y's, or inputs and outputs. So an ordered pair is always represented as an input and an output, which we know is normally on a graph, an x and a y. So any relationship between an input and an output is a relation, okay? So any relationship, any connection between x's and y's, I spelled between wrong, or between inputs and outputs, we can say, will represent a relation. So when we talk about relations, that's sort of a bigger subset. And functions are a subset of the relations, okay? So a lot of things, anything that has a relationship with x and y can be a relation, but only some things can be a function, all right? So a function, as you can see here, a function is a relation, so there's a relationship between the x's and the y's where one output is given for each input. Okay, so for everything you put into an equation, for every x, there is only one y as the output. All right, so that's what makes a function, whereas a relation, you could put in an x value and get multiple y's that are the same each time. So relations and functions, closely related. Functions is just a more specific name or more specific set of equations, graphs, tables, any, relating x's and y's, anything relating x's and y's. And every x, for every input, there is only one output. Okay, so for everything you put into that function, there's only one possibility for getting an output. And it makes it really clear, right? So if we have a function rule, well, for everything I put in, I get this specific thing out. That's a really clear statement. A relation isn't as clear. You might put something in, and there might be 4 or 5 different options for what you could potentially get out. Well, that's not really giving you an easy way to see something. So functions are much more helpful, and that's what we're going to focus on this unit. All right. So one of the things we can use to determine if a graph is a function is called the vertical line test. All right. And so the vertical line test is going to tell us when we pass it over a graph, so when a vertical line crosses a graph, it can only cross one point at a time, right? And that's because for every input, for every x value we have, there can only be one output if it's a function. If it crosses more than one point at a time, then we would consider it to be not a function, okay? So let's try that in practice. I have some graphs here, and you can sketch these in your notebooks too. And so one of the things I want to point out is you can see on these first couple graphs, they have actually noted specific points. That doesn't mean these are the only 7 points on this graph, okay? Because we've connected the whole thing with a line going through it, because we call that continuous there. Every single point in between these, so all the little points that would fall in here, and in here, and in here, and all the way on up, those are all going to also be points on this function. So I'm not just focusing on those particular points that end on a perfect little corner there. I'm really looking at the graph in its entirety, okay? So here's a vertical line, and what we're going to do is we're going to start on this graph, and we're going to pass this vertical line across the graph, and we're going to check at each point and say, okay, well, is it ever going to cross through more than one point at a time? So let's start at the beginning. Here I'm good, here I'm good. Only passing through one part of the function at a time, or one part of the relation, right? Still only passing through one part of the relation at a time, still only passing through one part of the relation. And I'm just looking at that blue graph. Doesn't matter about the x and y axis. I'm looking at what I've drawn on that, right? We, so far, have only crossed over one point at a time. So in that case, I would say, hey, yep, that is a function. Oops. And that's because every single x value only had one y value, right? So -2 as the x, when x is -2. Oops. Y was 0. There was only one y value it could be. When x was 1, right here, y was -1. There was only one value it could be, and that was true for every single point all the way across, okay? So let's look at its friend over here. This particular graph is, so the first one was an absolute value function, and the second graph is an absolute value function, but it's the inverse of that function. And we'll talk about that later in the year. But let's run this, let's just see if it's a function, okay? So we know it's a relation, let's see if it's a function. So I'm going to drag this vertical line across the graph. Right at that first vertex point, it's only hitting one spot. But as soon as I go past that, look at what's happening, right? I'll go to the green dots so you can see a little more clearly. Right here, when x is 2, there we go. So right there, when x is 2, we have two possible outcomes for y. It could be 1, or it could be -1. So because we have two outputs for one input, that makes this not a function, all right? That vertical line hits more than one point at a time. It is not a function. So let me see if I can grab this one more time. I'm going to take those dots with me, though. Oh, shoot. Let's see how careful I can be about this. There we go. Okay, there. And now we can see that would still happen here. We're still hitting 2 points at a time. Still happening here, even though I'm not on the green dots. We're passing through 2 points of the graph at the same time. And here, and here, and here, and that's going to continue forever. So there's an infinite amount of points we're hitting at the same time. That makes it not a function. Let's try the circle. Again, very beginning, it's okay. It doesn't matter if you go left to right or right to left. It should work the same. But, oh, boom. When x is 4, we have two different values for the function, right? We have one value down here and one up here. When x is 3, we have one value down here and another up here. So that one would be not a function because it's failing the vertical line test. And let's try this. So you might have heard of a quadratic function or a parabola. Again, this is the inverse. This is flipped on its side. So the beginning is okay, but any point past that, I'm now hitting more than 1 point at a time, right? So we would also say this one is not a function. So anytime you have a graph that fails the vertical line test, it hits more than 1 point at a time, you can say it's not a function. If it passes, like this first graph we did up here, then it is a function.